Ladies and gentlemen, welcome to section 10.4 Radical Equations. We're going to start off with a vocab word right away, and our vocab word is radical equations. Radical equations are equations that contain variables in the radicand. So please remember, we have an equation now because we have an equal sign, and since we have a radical sign, if we have a variable underneath that radical sign, which we do right there, which is x, we have radical equations. So let's take a peek at some of these problems. Here with number 1, we are asked to solve this guy. With this guy, we want to get the radical, the square root, this guy right here all by itself on one side of the equation. Is this guy all by itself on that side of the equation? Yes, it is. So let's go ahead and start solving for this. And how do you solve for something like this? Well, the very first thing we want to do when we get the square root by itself is to get rid of the square root. How do we get rid of the square root? Well, we get rid of a square root by squaring it. What we do to one side, we have to do to the other side. So we have to square the other side. Now the square completely removes the square root. So now we'll be left with a plus 5 equals, and then 5 squared is 25. Once you do that, you did the hard part. Now we just want to solve for a. So I'm going to subtract the 5 over to the other side. And then we have a equals 20 for our final answer. Jumping to number 2. Now please notice here on number 2 is the square root all by itself. No, it is not, because it has that plus 2 right here. So what do we have to do with the plus 2? We have to add it over to the other side, so we now get the square root. Notice how this square root is all by itself, c minus 3, and that c minus 3 is all under that square root equals 6. How do we remove a square root? We have to square both sides, so we come up with c minus 3 equals 36. Solving for c, we add the 3 over, so c equals 39 for our final answer. Number 3, again, the square root is not by itself because we have this 4. Now this 4 is in front. Does it change anything of the square root? It does not, so let's just go ahead and subtract the 4 over because that is a positive 4. So we subtract it over. Now it's the square root of h plus 1, and that equals 10. How do you remove a square root? You have to square both sides. So we square both sides. So now the square removes the square root. So it's h plus 1 equals 100. Solving for h, we subtract 1 over. So h equals 99 for our solution. Now with number 4, take a peek at number 4. What looks different from 4 going back to 3? Notice here on 4 where we have an extra variable on this side. Notice no variable here. Here we have an extra variable. Ladies and gentlemen, when that happens, we have to do something a little special. What we have to do, we still have to get rid of the square root, right? So I'm going to square both sides. But when I square the right side, ladies and gentlemen, when I square the right side, I have to square the whole thing. So on the left side of the equation, I have t plus 5. But now, on the right side of the equation over here, I'm going to have t plus 3 times t plus 3, because that's what this square means. When you do that, now we have to multiply everything out in the red. We have to FOIL it. So we have to go t times t, which is t squared, t times 3, which is plus 3t, 3 times t again, which is plus 3t, 3 times 3, which is plus 9. I'm going to simplify that jargon to give me t squared plus 6t plus 9. Bringing down what's in the black over here is going to be t plus 5. Now I am going to move all of this junk over here. So I'm going to simplify to get t squared. Now it's going to be plus only a 5t because I subtracted that t, and I'm going to subtract that over to give me plus 4. What's that going to equal? Since I subtracted it over here, it's just going to give me 0. What I have to do now, I have to factor this to find solutions to see what this what will make this equal to 0? So I factor it. How do we factor it? We have to multiply up to that 4, and it has to add up to 5, correct? So I have t plus 4 and t plus 1, because 1 times 4 is 4, but they add up to 5, still equaling 0. Do we remember what to do with these factors? It was a chapter ago where we go t plus 4 equals 0, t plus 1 equals 0. Solving for t equals a negative 4 here because we subtracted it over. T equals a negative 1 here because we subtracted it over again. Now though, we have to check our answer, and why is that? We check it because we squared the variable. Anytime we squared the variable, we have to check our work. So let's go ahead and check our work. I'm going to check it right below number 3 as I box 3 off. So checking negative 4 first. How do we check it? All we have to do is plug it right in. So I'm plugging it into my equation. I have the square root of negative 4 plus 5 equals negative 4 plus 3. Here is going to be the square root of 1, which is all right, but the square root of 1, does that equal negative 1? No, it does not. So that is no solution so far. Now, let's try this guy, where I'm plugging it in. Square root of negative 1 plus 5, that gives me negative 1 plus 3. Here I have the square root of 4, that equals 2. Well, the square root of 4 is 2, which equals 2, so my solution is good here, so t equals negative 1. Now there's a special word for what we just went through. It's called extraneous solutions. An extraneous solution is a result that are not solutions to the original equation. So since how we got this t minus 4, it was an extraneous solution, so therefore that is not a solution, but t equals negative 1 is a solution. Let's try one more problem like that just to make sure we have it down. So we have a square root by itself. What's our very first thing when we have the square root by itself? We have to square both sides. What you do on one side, you have to do the other. Notice how I'm squaring the whole thing over here. Also, I have a variable that I am squaring, so that means I'll have to check my work. So on the left side, I have x minus 3 times x minus 3. On the right side of the equation, I just have x minus 1 because the square undid the square root. Now I multiply everything out. I FOIL x times x, which is x squared. X times a negative 3, which is negative 3x. Negative 3 times x is negative 3x. Negative 9 times negative 9 is a positive 9. I'm sorry, that's negative 3 times negative 3, which is a positive 9, equals x minus 1. Simplifying on the left side to give me x squared minus 6x plus 9. That's going to equal x minus 1. What do we have to do? I'm going to move everything over here to equal 0, moving everything over there. So it's going to be x squared. I subtracted the x to give me a negative 7x. I added the 1 to give me plus 10 equals 0. Now let's factor this jargon and set it equal to 0. What multiplies to 10 adds up to a negative 7. Well, that's going to be a negative 5 times x minus 2, because negative 5 plus negative 2 add up to negative 7, but multiply to positive 10 equals 0. Keep going with this. I have x minus 5 equals 0, because we want to solve for x, and x minus 2 equals 0. So here we have x equals 2, and on the other side, x equals 5. We have two answers. However, do we have any extraneous solutions? Well, we have to double check. So double checking the 5, I have 5 minus 3, because I'm plugging it into the original equation, equals the square root of 5 minus 1. 5 minus 3 is 2, equals the square root of 4. Hey, we might be onto something. 2 equals 2. So x does equal 5. That checks out. That is good. Let's try just a 2. Here we have 2 minus 3. That's going to equal 2, or the square root of 2 minus 1. Here we come up with negative 1. Here, and on the other side, we come up with the square root of 1. Does the square root of 1 equal negative 1? It does not. So x does not equal 2. So our only solution is x equals 5. And then one more here with number 6. The question is, would you have any extraneous solutions with the equation, the square root 2 minus y equals y? Well, what would you have to do to solve this? We have a square all by itself, so we would have to square this side and square this side. When we square a variable, would it give us any extraneous solutions? Yes, it would. So the answer to this problem would be yes. You would have to double check your work. However, that does it for section 10.4, radical equations. Good day.